Now we will take one very important example, or maybe a kind of proof which we do in real numbers, and that is based on the definition of rational number and irrational number. So that's actually very important, and so let us take it. But before that, we will try to learn some what is rational number and what is the definition. Okay, so basically the definition of a rational number is that rational number is a number which could be expressed in terms of P and Q, where Q is not equal to 0. And why is that? Because if Q will be 0, then this will become infinite. Okay, so that we don't want. Okay, so Q is not equal to 0, and then P and Q are a kind of whole number, okay, or natural number. So any rational number could be expressed in the form of P and Q, okay. And if it is the opposite is also true, if a number is irrational, then it could not be expressed in the form of P divided by Q, where P and Q are natural numbers. Okay, so that is the basis. It is little tricky, but that is the beauty of mathematics. That's why I will go very slow here, so that you understand 100%. Okay, so so we already know the definition of a rational number, which is in the form of P by Q, whereas irrational is could not be expressed in the form of P divided by Q. Okay, so that is one thing. Another important thing is what is mentioned in the chapter 1 as theorem 1.2. What is that theorem? That's also very important. Okay, so theorem 1.2 says that let P be a prime number. Okay, let P be a prime number. What is prime number? Prime number is the number which cannot be further factorized. Okay, so we already saw at in the last video. So let P be a prime number. Okay, then it goes on. If P divides a square, if P divides a square, and what is a square? A square is, again, a is a kind of natural number and then squared. Okay, so it is telling that if this is true, if P divides a square, then P divides a also. That's very important. Okay, if P divides a square, then P divides a also. It could not be that P divides a square and then P do not divide a. It is not possible. Okay, so that is one basic thing. Let us try to see some example of that. Okay, so for example, P, let us assume that P is maybe 3. Okay, and then a square, let's assume 9 square. Okay, so then 3 divides 9 square, isn't it? Obviously 27 times. Then 3 will also divide 9. Yeah, looks correct, isn't it? Okay, let us take some different example, means where it do not happen. Okay, if let us take one more example, maybe 5. Okay, and then let us take a number which maybe 25 square. Okay, so 5 divides 25 squares, then 5 will certainly divide 25 also. Okay, this is what it states. Okay, so now you have understand that if this is true, then this will also be true. It has to be true, and vice versa. Okay, so based on this theorem 1.2 and definition of rational number, we try to prove a very important problem mentioned in exercise 1.2. So that is basically the exercise which we need to look at. I will just take question number 1. Okay, question is very simple. Prove that square root of 5 is irrational. Okay, and here you will learn the trick also, which is not only applicable in mathematics. Mathematics has the highest discipline whatsoever. Wherever you can see, you need to be disciplined in your thinking so that you can solve the problems. Okay, so, and it's all about logic. Okay, so here we need to prove that square root of 5 is irrational. Okay, irrational. So what we will do, let me just take it in red color. What we will take the approach of, let us assume that square root of 5 is rational. Okay, and then let us see based on that what happens if we treat it as a rational number. And if something unexpectedly happens, then we were wrong in our assumption. Okay, so let us assume that square root of 5 is rational. Okay, so if it is rational, then it could be expressed in the form of p divided by q, isn't it? That is the definition of rational number. Okay, now I will just go very slowly here because it's a little difficult to understand, but so that's why I will just go a little slowly. Okay, so p by q, again let me remind you again. Okay, a rational number should be or could be expressed in the form of p divided by q, where q is not 0. Okay, and if it is not that, then it is irrational. If it is, it could not be expressed in the form of p by q. Okay, where p, q don't have any common factor. Okay, p and q are co-prime, means they don't have any common factor. That is also very important. Okay, so now we have to prove that square root of 5 is irrational. So what we do, we start with the fact that, let us assume that it is rational. Okay, and then let us see what happens. Assume that square root of 5 is a rational number. Then it could be expressed in the form of p by q. Let us square both sides. 5, then p square divided by q square. Okay, so that's okay. Till now, no problem. Now you see, then comes a very different or concept, or maybe I should say just rearranging it. 5q square is p square. Now, according to theorem 1.3, I am again repeating, according to theorem 1.3, if a number divides a square, then that number also divides a. Okay, so we will take that fact. Okay, so here what we see, this number, at least we know that 5 divides p square. Okay, because it's equal, and then 5 is a factor here, so there must be some factor here also, isn't it, on this side also. Okay, so let us assume that p is 5 times some number, maybe t. Okay, then we can write down that, okay, let us write down, yeah, p is a factor of 5 and then square, and then it becomes 25 t square. Okay, now what we see, 5q square is equal to 25 t square. That we can write, isn't it? Maybe just pause the video and look at it. You will understand, maybe by looking at it 1 or 2 times. Okay, so now we started with the fact that this is a rational number. Square root of 5 is a rational number, and using theorem 1.3 we ended up here. Okay, we ended up here. So what we see here, there is a common factor of 5. Okay, but if it has to be or need to be rational number, there should not be any factor, any common factor. It should be able to be expressed in the form of p by q, where p and q don't have any factor in common. Okay, but here we see that, yeah, there is some factor in common. Okay, how did we get so contradictory things? But one thing is certain, that if we have got contradiction, then what we started with was not correct. What we started with? We started with the assumption that, okay, let us assume that square root of 5 is a rational number. Okay, and then we are getting very, very awkward and absurd result and wrong results, which is not justifying it to be a rational number, because it has, why? Because it has a common factor, and rational numbers should be able to be expressed in such a way that they don't have any common factor. It means square root of 5, we assume that it's a rational number. It's wrong. It means it's wrong. What does that mean? It means that if square root of 5 is not rational, then it has to be irrational. Okay, so proved. So you see, this is also one way of mathematics, that we start with something which may or may not be wrong, and then we apply few things which we know that it is correct, and then if we end up having some absurd result or wrong result, then it proves that what we assumed in the beginning, like we assumed here that root 5 is a rational number, that is wrong. Okay, and thus it is irrational number. So this is a typical way of logic. Okay, so by that we just stop here. Chapter 1 is in a way completed for the real numbers. Okay, so see you in the next chapter.